Good afternoon, everybody. So I'm Gillo, and I must confess that yesterday was my birthday. So as I was preparing for this speech, I was picturing myself, back in time. And I'm going to ask you to do the same. Where were you 20 years ago? So try to picture yourself, right? 20 years ago. No LinkedIn, no Facebook, no drones, things like this. Since then, our life changed a bit. Personally, 20 years ago, I was just starting my career as a software engineer, and my very first job was to implement an HTML server into a very tiny bit of CPU of 64 kilobytes of memory. And I've seen, obviously, like many of you here, the growing size of our capability in software development. Obviously, not only the software, but all the hardware related to it really came over in our lives. So here, picturing myself, at home with a connected counter for water, for electricity, my smartphone, my laptop, all of this together is now part of my daily life, and I guess for many of you as well. Sometimes because you made a choice, sometimes because you were obliged. Like in France, for example, we are now obliged to have a connected counter for electricity. And I guess it's pretty much the same in many of the Western world. So, and why am I talking about this to you? It's because my role today is not to talk about primary energy demand or energy efficiency, etc., but everything else. All environmental indicators that we can and should use when we try to draft sustainability for our own activity, for our nations, for our continent, and for the world, basically. So the first message is digital is material. We've been talking for the past 20 years about cloudification, digitalization, and for many people it's like hardware suddenly disappears. Because now it is somewhere in the cloud and I get this access to services and things like this. But as this has been already mentioned quite a few times today, digitalization requires quite some hardware resource. And I want to quote here one study performed out of France by the French equivalent of the UB. The name is ADEME. Their role is to help the country understand better how to use for the better world, energy and environmental considerations. And in this nationwide study, they realized that on average, a French person, if a French person can be average, consumes, yeah, I know. You may realize I'm French, right? Consumes nearly 1 ton of material. And that includes minerals, fossils use, but also water use. When you just create the equipment and you distribute it, at the end of the year, each single adult in France would have consumed the equivalent of 1 ton of material. And this is something that, when you're not aware, obviously you can buy this and buy that and you're okay, and then you can even create a circular economy. The message here is, let's be aware of what we're doing. There is 2 numbers here. One is about the waste, electronic waste, and all the waste about what we use or do not use. And the second one is about the natural resources that we actually extract from the earth every year for our digital usage. Now, I must say, I'm a part of the people, I think it was Anita this morning, and said, or Laurie, finding someone who knows IT and software and knows environmental assessment, it's quite rare. I'm part of these guys. So I'm here to represent what we do here in Europe. So I will be talking a bit about some studies out there. But I wanted to show you the several environmental indicators that we use when we perform an environmental assessment today, not including biodiversity, knowing that biodiversity is a complete other set of practitioners are doing differently, but this is going to be also included in Europe thanks to the CSRD mentioned earlier as well. But here you can see, we have a dozen of indicators, and the one in bold dark here, climate change, resource use, and water use, are the three ones that we typically use when we try to assess digital technologies from an environmental standpoint. And then you can see at the bottom here in a tiny bit, ITU, so the International Telecom Units, they recommend that we also integrate primary energy demand. Primary energy demand, it doesn't mean the energy that you use when you plug a computer or a server somewhere. It's really all the losses that you have between where you produce the energy and where the energy is actually used. So these four, water use, climate change, minerals and metals, and primary energy demand, are basically the four indicators that we use in each and every study performed out of Europe nowadays. Now, some insights on this study. So on the top left here, you would see one study which is going to be published, I hope, in January next year, 2024. That was my birthday, so I don't want to grow older and older. So, and this study is about having an outlook as to how moving from cloud computing to edge computing is going to change our microeconomic situation, our environmental footprint as a continent, but also the geostrategical new considerations. We've been putting everything in the cloud. I think it's not really a secret that a lot of companies owning cloud servers today are not really in Europe. And if we move to the edge computing, how does that change? So this study has been ongoing for almost a year. I've been a critical review for this from an environmental standpoint, and you will see that we can learn quite a few things, in particular in terms of growth of edge devices, Internet of Things devices, and things like this. Another one, which is already published, the one on the right-hand side, assessment of the energy footprint of digital actions and services, also produced by the EU Commission. And in this study that you can find online, you would see the different energy demand depending on the activities that you do online, video streaming, video gaming, and things like this. And then you could see on a unitary basis, which is basically if I watch 1 hour of video streaming online, or if I play a video game during 1 hour, or if I extend the lifetime of my smartphone for 1 year, how does that compare? What is on average here in Europe, what is the energy used by these different activities or saved by performing such or such activity? And on the left, the GRC, so the Joint Research Center in Europe, is currently performing a study to understand what indicators we must enforce to the mobile network operators in Europe, so that they consider the sustainability of the services that they provide, including, creating the networks, operating the networks, decommissioning the networks, etc., etc. And for this one, I'm also an invited expert to discuss with the operators to see how we can help them create the awareness and the calculations of all of this. I wanted to mention as well the fact that it's not only Europe, but even the US and China are working quite a bit on this. China has already, published different laws about energy demand on the digital sector, and the US has created the Green Communication Act, which is what you can read here, the generating resilience and blah blah blah. But they are pretty much trying also to raise awareness and to enforce some things out there. And the last one I want to emphasize, and I will deep dive into this one, is another French study where they've looked at prospectively where we are going in 2030 and 2050 in the digital sector if we try to create more sustainability and to achieve the Paris Accord by 2050, so that 2100 is still somewhere where we can live today on Earth. So what I'm publishing here, I'm sorry if it's difficult to read, but I will describe it briefly. So ADEME created 4 different scenarios in terms of creating digital services for the future. And these 4 scenarios supposedly can lead us to the Paris Accord. So if we follow these scenarios, we should have the IT sector in France compatible with the Paris Accord. But these 4 scenarios take completely different society choices. So the one on the top here, which is the repairing bet, I'm sorry if there is a grammar spelling here. So the repairing bet is basically technology is going to save us. So let's continue our current trend, and we will find different set of technologies that will help us with energy efficiency, with less travels, and so forth and so forth. And in this scenario, we can see that on the right-hand side, usage of digital technologies is going to blossom, like a lot of different usage. At the bottom here, we have what we call the frugal scenario, where we do as less as possible from a technology standpoint, and we rather use sobriety or acceptable actions in terms of digital service. Still, even if we do this scenario, we're still using Internet of Things technologies, for example, still to help remote control and remote reporting of energy consumption and things like this. And then in the middle, you have 2 different scenarios. One is about we create more collaborative actions between territories, corporations, and things like this. And the other one, which is green technologies. So we stop everything which is futile, and we focus all our energy into creating green technologies, including obviously digital technologies. These 4 scenarios, are supposedly going to help us with the Paris Accord. But as you can see here, number of devices might explode by like a multiplier of 40 if we go on the repairing bet. A lot of usage. But on the bottom one, we are going to use much more eco-design type of actions. We want to expand the lifetime of hardware, etc. And it should help us as well go into the scenario. What I wanted to do here, in showcasing these 4 different scenarios, it's not technology for technology. We've been talking about energy efficiency, green coding, and how technology can help or not help, etc. It's really a matter of choice. Earlier, Max said it's probably the most political roundtable that he had. This is about this. It's a political choice as well. What type of society do you want to build together when we use these technologies? And once we make a choice, how can we make it the most sustainable as possible? Now, obviously, as we said, IT technologies can help, and they come with a cost. So the cost, we call it direct effect. So when we introduce technology, there is a direct effect, which is you need to extract the material, you need to produce it, you need to distribute it, you need to use it, etc., etc. And then there are what we call indirect effects. And indirect effects can come with different natures. A lot of people in the industry would tell you, well, software and IT, etc., can help travel less for operational standpoint. So we do less oil and gas consumption. So it's very positive. And sometimes it's a different one. So now let's deep dive into this. But before I deep dive into the different effects, maybe talking a bit about why I'm legitimate to talk about this. So I'm Gillo. I've co-founded a company 3 years ago called Mavana, and our raison d'être is to help organizations, whether they are private, public, or even non-profit organizations, in identifying their environmental impact and help them assessing the cost, the benefits, or the potential damages in introducing digital technologies in their daily operations. And as we do that, we really, we map the activities and we look at, every single process in their activity and really identify what we call the heating points of where there are more and more environmental impacts, and we try to help them reduce that. So to do that, we do a lot of quantification. So GHG protocol, GHG footprint evaluation, life cycle assessment, and things like this. But there are a lot of times where even before doing quantification, we need to raise awareness. I think it's at least the 78th time that we've said awareness today. So we raise awareness with different workshops. Max mentioned the digital collage. If you don't know digital collage, come and see me. It's very powerful workshop. You know, in 2-3 hours, people get to understand the social and environmental impacts of digital technologies. And then we also help companies and institutions into creating studies and things like this. And this is why I'm helping the French government or the European Commission on this. And I'm originally a software developer. This is why I'm here. You can't read this, I'm pretty sure, because it's very small and in French, but I will explain it to you. So what we do when we try to assess these costs, benefits, and damages, we start by looking at the reference scenario, how people are doing today. And this is the first bar that you see here on the left. So these are, so said, the current environmental cost of the reference scenario. And then we introduce digital technologies. So that's the second tiny bit here. So at first, you increase the environmental cost. Now, by nature, you introduce something, you need to produce it, to integrate it, etc. And then there are supposedly benefits. So you reduce the environmental cost. So if I take the example of video conferencing, the company operates, without video conferencing. You introduce video conferencing, so you have the software running on the laptops, you have a server, sometimes you have devices and things like this, so you increase the cost. And then you say, now we have video conferencing, we don't need to travel anymore. We can actually have a summit like this, everybody is remote. So then you reduce the environmental cost because people are stopping traveling. But then as you do that, you say, actually we can invite even more people now. Or we can create more meetings because now it's more efficient. Then you create an additional burden that some of you may know as the rebound effect. So that's an example. And then as you do that, you say, yeah, but we can change habits. You can actually do homeworking. Then you create another indirect effect. So we have the direct effect, the indirect effect, and the indirect of the indirect effect. You get what I'm going here, right? And then sometimes the indirect of the indirect effect, such as in track 2 earlier, they said, no, you reduce you save money because you are more efficient, and you guys do not need to buy more computing power, for example, in a data center. What do you do with this money? Well, sometimes you create other activities. And then you have the rebound effect of the rebound effect. So our job is really to help companies understand that. So either afterwards, so they've done something and they want us to look into, were we right and should we continue, or proactively. We plan to do something. What do you think about this? So sometimes it's positive, like this one. So you have this reference scenario on top, and then suddenly at the end, considering all the indirect effects that we can model out, then you have a positive impact. And sometimes it's negative. So our role is really to help the companies understand where they have things to do, things to change, to really understand, and be more sustainable eventually. So I want to, and that's going to be almost the end of my speech here, I want to give you a case study in the pharmaceutical industry. So this large company came to us and said, I have these factories out there everywhere in the world, and because we produce medicines, and these medicines have to be produced in a very specific range of temperature, we use air conditioning, HVAC, to really regulate the temperature within the factory. And 3 years ago, we've introduced Internet of Things, connected objects, to automate these air conditioning systems. And before that, we were having a technician, driving around, and this technician had kind of a craftsmanship skill. So just by listening to the machines, it would tell you, this one is going to break down next month, so you should do this thing, etc., etc. This guy was like top of the edge. But it was only one guy. Well, the guy can also teach to someone else, etc., etc. But it's one guy that needs to travel across different states in the US, for example. So they created this IoT connected devices to automate and to be more efficient. And when they asked us to look into the results, so we've audited a factory in the US, another one in Canada, another one in Belgium. And we look into the details, considering everything that I said to you before, reference scenario, introducing the technology, reducing and then increasing again. And at the end of the day, we realized that out of the 4 factories that we've audited, only one had a positive impact net at the end. Why is that? Because this factory had only 1 or 2 buildings, and the number of devices that were required to actually automate was fairly small. The other ones, where there is a high density of buildings, but then you need 10, 20 different devices within the factory, were much less efficient than just having one guy traveling. So with this new knowledge, this company was like, interesting. So I've been losing money in the past 3 years, and I have been increasing my environmental impact, whereas I was thinking that I was doing the right thing because I'm not using gas anymore to travel out there. So what we've done for them is kind of a configurator. So, because at the end of the day, with the same technology, but different conditions, you get to a different outcome. So technology by itself can be positive, can be negative. It really depends on what are the conditions of operations that you are doing in this. Last consideration, but I guess a lot of you know that, when you create a system, sustainability has 2 best friends, data privacy and accessibility. If you address these 2, then probably you would not keep a lot of data. You will make sure that it is as small as possible and as readable as possible, and potentially your system is going to be more efficient and last for a longer time than the other one. Thank you. Last consideration, and this one is the very last. I did travel to come here. And I was, again, yesterday was my birthday, so I did make some sacrifice here. Please help me compensate for my travel. It's very easy. 10 kilograms of CO2, each one of you, if I'm not mistaken. So that could be, if you want to buy a new smartwatch, don't do it. Or if you have a smartphone, just extend the lifetime. Next time you say, I want to change it, wait for another 3 months. It will compensate for my travel. Thank you.